So now I want to go through several common polyatomic anions and cations, showing you the name and the structure. But first, what is a polyatomic cation or anion? Well, a polyatomic anion is an anion, meaning it has a negative charge, it has gained an electron, but it has more than one atom. So polyatomic, more than one atom, so they're covalently bonded. So this O is covalently bonded to an H, but it has an overall negative charge. So this OH stays together in chemical reactions. NO3 stays together in a chemical reaction, but it overall has a -1 charge. So you need to recognize when you see something like NaNO3 that that's an ionic compound, that there's an Na plus cation with an NO3 minus anion. So anions are negatively charged. They have gained an electron. If there's more than one atom consisting of that anion, then it's called a polyatomic anion. A cation has a positive charge. It has lost an electron. So let's go through some of these common polyatomic cations and polyatomic anions. So a polyatomic cation, ammonium. This is one of the most common polyatomic cations that you'll see. So whenever you see NH4, know that it has a plus charge and it is a polyatomic cation, ammonium. Here's the structure. Notice there's a positive formal charge on this nitrogen. If you count the electrons directly around the nitrogen, 1, 2, 3, 4 electrons. There should have been 5 because remember nitrogen is in group 5A. So you have actually lost 1 electron around this nitrogen, so it has a positive charge on this nitrogen. It has lost an electron. H3O plus is hydronium. It has a positive formal charge on this oxygen because this oxygen has lost an electron. Oxygen is in group 6A. 1, 2, 3, 4, 5 electrons are directly around this oxygen, so it has lost 1 electron. It has a positive formal charge. But remember, when you're counting up the number of electrons that this oxygen feels like it has, you count the ones over here because it's shared. Remember, a covalent bond, you're sharing electrons. So oxygen has 2, 4, 6, 8 electrons is what it feels like. It's got its complete octet, but when you're assigning a formal charge, you just count 1, 2, 3, 4, 5 electrons directly around the oxygen. It should have had 6. Electrons are negatively charged, so we have lost 1 electron. It has a positive formal charge. Hydronium, H3O plus. And those are the two very common polyatomic cations, ammonium and hydronium. Now let's look at some of the polyatomic anions. Hydroxide, nitrate, nitrite, permanganate, dihydrogen phosphate, hydrogen sulfate, hydrogen carbonate, or bicarbonate as well. This could be called bisulfate or hydrogen sulfate, bicarbonate, cyanide, acetate. It could be written CH3COO-, or you could take these 2 carbons, put them together, say C2H3O2-, or just OAC-. So these are several common polyatomic anions with a -1 charge. Now let's look at their structure. Acetate. Notice there is a negative formal charge on this oxygen that has 3 lone pairs and a bond. So it has 1, 2, 3, 4, 5, 6, 7 electrons. It should have had 6. It has gained an electron. It has a negative formal charge. So acetate, CH3COO-. Cyanide, Cn with a negative formal charge on this carbon. Bicarbonate or hydrogen carbonate. has a -1 charge. It has one oxygen that has gained an electron, CO3 or HCO3 minus. This acid or this H could be lost, so it could act as an acid, or this electrons could pick up an H, so it could act as a base. So that could either act as an acid or a base. Bicarbonate. This is what's in baking soda. In baking soda, this negative charge is neutralized by a sodium cation. So you would see an Na plus with an ionic bond to neutralize that negative charge on this oxygen. Bicarbonate. Bisulfate or hydrogen sulfate, HSO4 minus, has a negative formal charge on one oxygen. H2PO4, see if you can remember. Dihydrogen phosphate has one negative charge on one of the oxygens. H2PO4. MnO4, permanganate. NO2 minus, what is that? Nitrite. That's right, nitrite, NO2 minus. Right, nitrate, NO3 minus. Notice that there's a negative plus and negative, so these two cancel out and you have an overall -1 charge. Some ask, well, why didn't you just put these electrons between this nitrogen and this oxygen? Well, you can't do that because nitrogen can't expand its octet. So this electron goes to the more electronegative oxygen and you'll have this separation of charges, but that's because nitrogen cannot expand its octet. But nitrate is NO3 with 1 minus charge. OH minus, very common, really need to know that one. Hydroxide. It's a very strong base. And this is its structure. Has a negative charge on an oxygen. It has gained 1 electron. Let's go through some polyatomic anions that have a -2 charge. So -2 charge. CO3 2 minus. Carbonate has a -2 charge, and here's the structure for carbonate. CO3 2 minus. Let's look at C2O4 2 minus is oxalate. Here's the structure for oxalate. CrO4 2 minus. Chromate. It has gained 2 electrons, 1, 2, so it has an overall -2 charge. CrO4 2 minus, chromate. HPO4 2 minus is monohydrogen phosphate, has a 2 minus, HPO4 2 minus. SO4 2 minus is sulfate. SO4 2 minus, sulfate. It's a common polyatomic anion. So when you see Na2SO4, you would know that, oh, well, there are 2 Na cations to 1 SO4 2 minus anion. Now let's just look at one common polyatomic anion that has a -3 charge. PO4 3 minus. Is phosphate. PO4 3 minus. Remember, if you have 1 hydrogen on this structure, it has a 2 minus because it is this electron right here. See this electron, there's an extra one here. It picks up a proton. Remember, a proton is just an H plus. So these 2 electrons were on the oxygen in phosphate, but now it picked up an H plus, and it's called monohydrogen phosphate, HPO4 with a 2 minus.